This is a collision. As soon as I saw this as a collision, I just start thinking of momentum. Okay, it might not be the case, but as soon as I see any sort of collision like this, I start thinking of momentum. Right, there's a frictionless trolley. Mass, the first mass is 2 kgs, it says there, and it's going at 6 meters a second. It collides with this one who isn't moving, and then they stick together. The magnitude of the total momentum of the trolleys when they stick together after the collision. What do we know about the total momentum before? We know it equals the total momentum after. And we could have written it as sum of the momentum. Sum of the momentum. Right, so we don't really know enough information to work out from the velocity, the total momentum afterwards. But if we can work out the total momentum before, it is the total momentum afterwards. So that's how we're going to do it. We're going to say total momentum before equals total momentum after. Remember, P is momentum. Alright, so let's work out the total momentum before. It equals mv plus mv. Momentum is equal to mv, and there's two of them. The first one has mass 2 kgs times 6 meters a second, and the second one has 4 kgs times 0. So that's 12 plus 0 is 12. Okay, using calculations to determine whether this is inelastic or elastic. What that means is the kinetic energy the same before and after? So if I want to work out the kinetic energy before and after, I know kinetic energy equals half mv squared. I've got enough information to work out. I've got m's here, I've got v's here, so that's fine. I've got m's here, but I don't have the final velocity, so I need to work that out before I do this calculation. Right, so the first one is, let's find that final speed. The final speed. I'm going to do it using this momentum. Momentum before equals momentum afterwards, and I know that that was 12. So 12 equals the total momentum final, which is equal to mv. Okay, mass times velocity. In this case they're stuck together, so I can combine the masses. So 12 equals mass of 2 and 4 is 6. 6 times v. 6 times what equals 12? v equals 2 meters a second. Alright. No worries. Oh, let's leave a gap so it doesn't look as messy. 2. So now that I've found that, let's actually do the kinetic energy before and afterwards. So before, the kinetic energy equals half mv squared plus half mv squared, which equals half times the initial mass of the first one had mass 2, speed 6. 2 times 6 squared plus half times the other one had mass of 4 and speed is 0. 4 times 0 squared. So 6 squared is 36. 2 times a half equals 36 joules. And after, it's just one of them stuck together, so we can say kinetic energy equals half mv squared equals a half times the new mass stuck together is 2 and 4 is 6 kgs, and their velocity we worked out was 2 squared. So 2 squared is 4, times half is 2, times 6 is 12. They're not the same. So that's an inelastic collision. Calculate the magnitude and the direction of the impulse exerted on M1 by M2 during the collision. On M1 by M2. Well, this is the impulse, let's just do a little bit of working here so you can understand. The impulse equals change in P, which equals force times T. Now the impulse is another way of saying Newton's third law. Okay, the forces in a collision are equal and opposite, and the impulses are equal and opposite, and the change in momentums are equal and opposite. So to get the right number, to get the right magnitude, you could do it as on m2 by m1, and you'll still get the right number, but we'll just have to make sure the direction's right. So it doesn't matter which change in momentum we work out. This is what I'm going to end up doing, working out this change in momentum. It doesn't matter which one I use, they're going to give the same answer. So I equals change in momentum, and I'm going to look at the change in momentum on m2. Why am I going to do that? Because it seems really easy, because this momentum beforehand is 0. Just find that's going to be an easier calculation for me, so that's what I'm going to choose to do. So the momentum of m2, change in momentum of m2, which equals change in momentum of anything that's final minus initial. His final momentum is 4 kgs, and what's his final speed? His final speed is 2. So 4 times 2, because it's m times v. And his initial momentum, like I said, was 0. Just makes an easy calculation, which equals 8 kg ms negative 1. And the change in momentum of number 2 is equal to the change in momentum of number 1. It actually equals the negative. So 8 kg ms negative 1. So that's the number. Newton seconds kg ms negative 1, the same thing. And now the direction. So it's exerted on m1 by m2. So the other way we can look at the direction, it's the same direction as the force. Okay, force is equal to times time is equal to impulse change in momentum. Same direction as force on m1 by m2. So which direction is the force on m1 by m2? Well, m1 was going along here really, really fast. There's its velocity. And then afterwards, when it hit, velocity isn't as big. So therefore, if it was going this way, this is m1 by the way, before the collision, and then after the collision it's not going as fast, therefore there must have been a force to decelerate a little bit this way. M2 must have given this force to M1, that direction, on M1 by M2. So it's this direction here, which is left.